Hello everyone. Two belt conveyors are used for material transportation. Startup operation error can cause material accumulation. Stop operation error can also cause material accumulation. Each motor plays a different role. It needs to start or stop in sequence to ensure the reasonable operation process and reliable work. This task will use PLC to achieve sequential control. I/O address distribution. The two-belt conveyor problem can be solved using traditional relay contactor control. As shown in Figure 1, the typical sequence starts and stops in reverse order. In the control circuit, the KM1 normal open contactor is connected in series to the KM2 coil branch to form a sequential start. The KM2 normal open contactor is connected in parallel with SB2 normal close contactor to form reverse sequence stop. According to the circuit principle analysis, you can fill in the PLC I/O distribution table. Input: M1 start button SB1, start, I0.0. M1 stop button SB2, stop, I0.1. M2 start button SB3, start, I0.2. M2 stop button SB4, stop, I0.3. Output: KM1 contactor, control the motor, Q0.0. KM2 contactor, control the motor, Q0.1. PLC external wiring. The terminal L plus M is connected to a 24V DC power supply. I0.0, I0.1, I0.2 and I0.3 terminals are connected to the corresponding button and then connected to the DC power supply with 1M terminal. The contactor chooses the direct current contactor. The terminal for L plus 4M is connected to a 24V DC power supply. Q0.0 connect with KM1 coil to the power supply negative. Q0.1 connect with KM2 coil to the power supply negative 2. Design the program. First, we should design two start keep stop program to achieve one-way continuous operation with M1 and M2. M2 will not start until M1 starts. Connect the normal open contactor of Q0.0 in series to the Q0.1 coil branch and disconnect the Q0.1 coil branch. Only Q0.0 connected Q0.1 can be connected. The implementation of sequential start. M1 can stop after M2 stops. Connect the normal open contact of Q0.1 to I0.1 in parallel. After Q0.1 is connected, I0.1 contacts to disable the stop function. Q0.1 can be stopped only after Q0.1 disconnects, realizing reverse sequence stop. Start button is often used by the hardware with the normal open button. The normal open contact used in the program is in line with the requirements. Start button is often used by the hardware with the normal open button, but in the program we need to use the normal open contact to meet the requirements. Input the program. 4. Program input. Perform hardware configuration first. Open the TIA portal software, switch to project view. Create a new project, project name Sequence Control. In the project tree, select Add New Device. Click on Controller's Somatic S7-1200 and select CPU 1215DC/DC/DC, Article No and Version. Article No and Version. Click on Profinet Interface _1, click on Add New Subnet, set IP address in the project. Click Add New Subnet and set IP address in the project. For complex control systems that use a large number of input and output points, the use of symbolic addresses will improve the convenience of reading, writing, and debugging the program. You can write the PLC variable table before writing the program. Open PLC tags, add new tag table. M1 start SB1, data type bool, address I0.0. M1 start SB1, date type, bool, address, I0.0. M1 stop SB2, data type bool, address I0.1. M1 stop SB2, date type, bool, address, I0.1. M2 start SB3, data type bool, address I0.2. M2 start SB3, date type, bool, address, I0.2. M2 stop SB4, data type bool, address I0.3. M2 underscore stop underscore SB4, date type, bool, address, I0.3. Contactor underscore KM1, data type bool, address Q0.0. Contactor underscore KM1, date type, bool, address, Q0.0. Contactor underscore KM2, date type bool, address Q0.1. Contactor underscore KM2, date type, bool, address, Q0.1. Input the program and click Program Blocks to open the main OB1 program editing page. Design two self-locking program blocks with normally open contacts and output coils, and set the corresponding addresses. Connect Q0.0 normally open contact in series with Q0.1 branch to realize sequential start. Connect Q0.1 normally open contact in parallel with M1 underscore stop underscore SB2 contact to realize reverse stop. After writing the program, click Compile to check the compilation information, and modify it timely until there is no error. Program Simulation Verification. 5. Program Simulation Verification. Click on the Start Emulation button to load the program, start the module, and turn on the program monitor. The green contact indicates on and the blue dotted line indicates off. Open the factory I/O emulation software and click on Start Emulation. Start and stop buttons are provided on the control cabinet door. When starting, press M2 underscore start underscore SB3 first. M2 and M1 will not run. If you press M1 underscore start underscore SB1 first, Q0.0 will be turned on, M1 will start, and Q0.0 will be turned on to prepare for Q0.1 to be turned on, and then press M2 underscore start underscore SB3 first. When M2 underscore start underscore SB3 is pressed again, Q0.1 is turned on and M2 starts. Then press M2 underscore start underscore SB3, Q0.1 turns on and M2 starts, realizing the sequence of M1 starting first and M2 starting later. When stopping, press M1 underscore stop underscore SB2 first, M2 and M1 will not stop. If M2 underscore stop underscore SB4 is pressed first, Q0.1 will be disconnected and M2 will be stopped. When Q0.1 normally open contact is disconnected, the M1 stop contact will be activated to prepare for the disconnection of Q0.1, and then M1 underscore stop underscore SB4 is pressed again to realize the sequence of M1 starting first and M2 starting later. Press M1 underscore stop underscore SB2 again, Q0.0 disconnects, M1 stops. Then press M1 underscore stop underscore SB2, Q0.0 breaks and M1 stops, realizing the reverse order of stopping M2 first and M1 later. Click M1 underscore start underscore SB1 to start M1 running, 1 hashtag conveyor belt running. Click M2 underscore start underscore SB3 to start M2 running and 2 hashtag conveyor belt running. Realize sequential start to avoid material accumulation during start. Click M2 underscore stop underscore SB4 to stop M2 running, 2 hashtag conveyor belt stops. Click M1 underscore stop underscore SB2 to stop M1 running and 1 hashtag conveyor belt stops. Realize stopping in reverse order to avoid material accumulation during stopping. Practice. Here are some exercises for this lesson. The content is how to control motor run in sequence with PLC, including I/0 address distribution, PLC wiring, program design, program input, program simulation, and verification of learning. Thank you.